All right, so yeah, quick note before we begin, we're going to be sharing a video that uses stereo sound, so we ask that you wear headphones if you have a pair accessible to you. So we are Mixthesia, an exploratory project focused on discovering intuitive interactions in virtual reality that introduces musicians to song mixing tools and concepts. Here's our team, and our faculty advisors were Heather Kelly and John Dessler. So agenda for the presentation, I'm going to begin with an overview on our project's goal and our vision throughout development. We're going to move on to talking about our prototypes and showing a demo video, then move into our lessons that we've learned and the takeaways we received from playtesting the prototypes, and then end off talking about our project's future going forward. So to begin, I'm Brandon, the Tech Arts on the team, and I'll start with the overview. So first, I wanted to give a quick overview of what sound mixing is within the music production pipeline. Mixing occurs after the composition and recording of said composition is complete. Sound mixing consists of manipulating each individual track within a piece of music in various ways. These manipulations can include volume, left-to-right panning, and adding effects such as EQ and reverb to the tracks. And we'll go a little bit deeper into these concepts later in the presentation. The image you see on the left is a digital audio workstation, or a DAW, that is a software used for mixing. And the image on the right is your standard mixing board, which is a traditional tactile device used to mix. Our project goal was to explore the opportunity to introduce musicians and music enthusiasts to sound mixing utilizing virtual reality. Sound mixing is often viewed as an advanced craft that is performed in close-off rooms for extended periods of time through a traditionally complex interface. By prototyping different visualizations and interactions, the project aims to take a step within the VR sound mixing space to demystify the craft by avoiding the complex interface of a DAW. And because of our approach to discover how to ease musicians into the tools and concepts developed in a DAW, these are the 3 key points we focused on throughout development. Our target audience for the product was the musicians who have a foundation in music composition, who wanted to explore the more technical side of music production. And while creating the documentation and outreach in various forums, our secondary goal was to inform future audio VR developers who want to build from our findings. So why did we decide to use virtual reality specifically? We decided that VR would be the best medium to demystify sound mixing to newcomers because of its heightened feeling of presence compared to that of a traditional 2D screen. From our personal anecdotes, along with testimonies from mixers and experts in the field who've taught sound mixing, a common way to learn these tools is to imagine certain visualizations in your head. We leverage those associations within our prototypes in order to immerse them in the visualization that is used to explain the tool. This feeling of physically being in an environment with the music can be used to help players picture what certain tools and concepts are doing to manipulate the sound. Guests now get to see how the placement of each instrument affects the overall mix in VR space, as opposed to reading a 2D screen of dials and sliders. I'll now hand it off to Shiva to talk a little bit about our prototypes.
Thanks, Brandon. I'm Shiva. I'm the audio programmer in the team. So throughout the semester, we built multiple prototypes that address different tools, specifically prototypes tackling volume and panning and 2 versions of reverb before halves. So panning is the distribution of audio signals in multiple channels. And in our case, it was stereo, that is 2 channels. So inspired by song layout, we built what we call the track field, which is used to control both panning and volume at the same time for a track. We then moved on to build a prototype for reverb. We chose to put the guest in the same physical space with the audio source to help guests better understand how the audio would change as they manipulate the properties of the space itself. After halves, we concentrated on automation and EQ, which I will talk about in detail. So automating parameters like volume and panning is often used as a very handy tool for both showing movement and dynamics in the mix. We wanted to draw the analogy of animating in 3D and take it to the audio world. In the traditional interface, automating multiple parameters can often get very confusing. And on top of that, using external hardware like the MIDI interface that you see over here, and to do it in real time is not very intuitive. So our solution to this problem was to use the track field that we had built earlier as a foundation and give the guests the ability to record and animate these parameters in real time and play them back to listen to the change. Moving on to equalization, many of us are familiar with EQ and have heard of it or used it on our TV or car sound controls. But in the context of mixing, they are one of the most important tools. Understanding where a particular instrument stands in the frequency spectrum becomes key to actually layering multiple tracks in the mix. Inspired by the concept of audio cube, which is often used as a reference while teaching and doing mixing, we wanted to show the effect of changing EQ in the context of other tracks. Uh, DAWs have a similar problem where it's easy to lose context of the overall mix, and it's also difficult to manage multiple plugins at once. Our solution here tries to give a better understanding of what happens to the entire mix when a track's EQ is changed and what effect it has on other tracks at any given point in time. We'll now show you like a quick demo video of the two prototypes that we built after halves.
We built automation on top of our first prototype where guests can drag a track around on a track field to affect its volume and panning. Automation allows them to pre-record these movements and automatically plays back the change during the given time period. In her waters, deep and true, lie the answers and a path for you. Dive down deep into her sound, but not too far. Deep and true, lie the answers and a path for you. Dive down deep into her sound, but not too far. The EQ prototype showcases two different approaches to representing EQ. With the help of the new AudioCube view we implemented in this prototype, both approaches visualize the frequency composition of individual tracks and grants guests control to modify certain frequency ranges of a track.
I'll now hand it over to Isabel to talk about our playtesting and documentation.
Thank you, Shiva. I'm Isabel. I'm the UX designer of the team. So we playtested with 3 different groups of people. For the industry professionals we reach out to, we inquire their sound mixing experience and discuss our design ideas with them. After we built the prototypes, we interviewed and playtested with novice musicians to understand more about their pain points. And we also recruited music enthusiasts to playtest in order to seek for more potentials of our prototypes. Playtesting for VR projects was challenging. Although we managed to get a lot of playtests virtually with their own headsets or by watching the recordings, the few in-person playtests were the most rewarding and efficient way to get valuable inputs. We adjusted our playtest strategies after halves. So first, we tried to set up more interviews with the playtesters and move away from relying too much on the surveys. That gave us more in-depth feedback on the content rather than just the interface. And second, we locked down a focus group of playtesters who are able to playtest with us throughout the semester. And here are some quotes from the in-person playtests. Our prototypes helped novice musicians build the gap between their initial knowledge with the sound mixing tool and also helped enthusiasts build their understanding of certain mixing concepts. We also received validations from industry professionals, acknowledging that track-field attributes simplified automation steps. And the Reverb Seno prototype is a successful transition from traditional sound mixing tools to our prototype. We organized all the prototypes into 4 documentations, which have been posted onto our website. Each of them lists out the design and tech specifications, the findings of the playtests and interviews, and also some of the future perspectives. We expect developers who are interested in these research to make good use of these documents in the future. And now I'll hand it over to Sam to talk about what we've learned.
Thank you, Isabel. I'm Sam. I'm the designer and programmer on the team.
For each prototype we built and tested, as Isabel just mentioned, we learned several important lessons, and I'm going to talk about some of those lessons. With the basic functions and volume padding prototype, we learned how much confusion reinventing mixing terms could lead to, as we came up with deactivate, and activate with the intention to simplify mute and unmute functionalities from a DAW, and our guests were generally confused. We also learned the importance of using small experience bits to establish the correct expectation from our guest, which is how we made stereo audio work in our VR experience. The prototype of Reverb is by far our most successful prototype, both in terms of the wow effects it brought to guests and also in terms of simplifying the concept of reverb. It's the prototype that, first of all, least resembles any sort of interface, and second of all, fully takes advantage of the immersiveness of VR by physically placing guests in a church and connects the change of reverb effects with that change of the space. We believe these are the two major factors that contributed to the success of this prototype, and that they should be a major design guideline for future attempts as well. With the automation and timeline prototype, the problem of requiring too much looking around and searching from our guests started appearing. While VR provided us with a wide range of space to utilize, it's not necessarily always the best approach to use all axes or ranges. In our case, we asked for frequent focus change from our guests while doing automation, which affected the smoothness and continuity of the sound mixing experience. And among all our prototypes, the EQ is the one where we face the most challenges, but also where we learn the most. We falsely assume that our target audience should be able to take in more information as the concept gets more advanced, and decided to flood them with multiple tools, including volume panning and EQ all at the same time. As a result, it not only quickly complicated the interface to make everything unreadable, but also failed to put emphasis on EQ, which is really the only tool we're trying to teach here. This prototype also prompted us to rethink how much information is really necessary for our target audience to understand a tool or concept. And now I'm going to pass over to Pavan to talk about our project future.
Thank you, Sam. I'm Pavan, the producer/project manager on the team. We envisioned our project as something that lasts not just for the duration of the semester, but extends well beyond it. And we ensure that by reaching out to the community. As first part of our research, outreach, we posted all of our documentation on our website and subsequently posted all articles and videos of our prototypes on multiple audio forums on Reddit and other social media. And for the second part, we created a Unity editor tool that would let developers import their own music stems into the prototypes and experiment with these tools and concepts while mixing them. This project will be available on GitHub publicly. Our intent behind this was to promote exploration and experimentation into the space by the VR and audio developers community. These actions would then act as a catalyst for using alternative tools like VR to enhance teaching music and mixing. After the end of the semester, as part of the audio and VR developer community, we invite our peers and colleagues to continue working on more prototypes and possibly create a sequential or modular learning experience. We also intend to present our findings at the Audio Developers Conference next year. And finally, the biggest forms of acknowledgement came in two parts. Firstly, we spoke to Professor Ben Opie of CMU's Music School, and he expressed great interest in integrating parts of our prototypes into his course, Introduction to Music Technology. This will be contingent to a playthrough early next spring. And secondly, we will be conducting a 1-hour session of a brief introduction to VR and mixing concepts with students of a music school in India. We would be screen sharing over Zoom and explaining the concepts in an interactive way to introduce and improve the students' understanding of mixing. We would like to thank these individuals for providing us with the crucial insights that inform the design decisions of our prototypes, and these individuals who helped us immensely by playtesting our prototypes. To summarize, we are Team Mixthesia, and we are exploring intuitive interactions for mixing in VR. Our objective is to ease the learning curve of mixing and share our discoveries with the audio community. We are now open to questions.
All right, great job, team. Congratulations. So anybody have any questions, throw them in chat or raise your hands and Dave will help moderate, facilitate.
Go ahead, Mike.
So you came in as a pitch project, so you really knew this space and probably had some preconceptions about how you thought VR could help with your demographic. Could you give a surprise, something that you thought was going to happen and didn't, or something that you never thought would work and did? What was something that you discovered from the work you did this semester?
Sure. So the question is like, was there any surprise coming into the project for something that we thought would work but didn't work? I think it became, it wasn't a surprise as such, but it was more of a clarity towards as we went through the semester of how more of real world associations of audio where things like echo or reverb that actually physically happen in the world is VR is like the perfect, could be the perfect medium for it to actually teach. Whereas stuff like compression or EQ is very, very digital, where it's like a purely digital signal processing effect. And through our prototyping, it became more and more clear that these are two separate things, but at the same time, it also helped even professional musicians actually believe that this can potentially be something that can actually be used as a professional tool eventually. Like, yeah.
Thanks.
Go ahead, Jesse.
I'm curious to know what you guys feel like you learned about mixing. What do you understand about it as a craft that you didn't understand at the beginning of the semester?
So I can answer. So personally, I think one specific thing about mixing that I did not understand before, or like before going through the project, was like this whole thing is like the workflow of like applying different kind of effects, and this came up while we're playtesting our river prototype, where in the prototype we showed only one track and asked our guests to play around with the effect to add the sense of space to it, and then through the feedback we got, we realized that it would make more sense if in the prototype we presented with like multiple tracks and sort of ask the guest to be able to move those tracks around in that same space, and this is because conventionally in the mixing process, and that is how the tool, this specific tool Reverb is being used, is by you group multiple tracks and then sort of use the same plugin to add the same sense of space to them. And this is something me personally did not realize that's some technique that you have to do while doing mixing, and something I eventually realized by doing this project and also playtesting with it.
To add to that, I personally also had quite a few revelations. I did not understand EQ when we started this project, and especially when we built our EQ prototype and I went into the build to review it. Like when we did the first build review, those floating orbs on those frequencies really nailed the concept for me. And until then, that was an aha moment to me.
All right, that's time. Thanks so much, team. Great job. Congratulations. So if you all can mute yourself, turn your cameras off. And next up, xroom, if you can turn your cameras on and unmute yourself, and I'll find you. Ah, I see one already. One, two. All right, that's all of you. Whenever you're ready.
Okay, thanks, Drew. Okay, can everyone see my screen? I guess that's yes. Okay, so I'll start. So thanks everyone. Welcome to Project Xroom's final presentation. We are a team of 6 people that come from diverse backgrounds. Our advisors are Carl and Tom. Our clients are Dr. Jessica Hammer and Interdigital Communication. Our client wished us to explore how to make fun interactive XR game in a room scale space, and they also wish us to utilize the technology of edge computing and do a showcase that they can showcase this game in a future conference. So we create a multiplayer interactive mixed reality experiences for mobile devices that people can enjoy in a room scale space. We call our game Disco Arena. During this SR Discovery project, we will present in these 3 topics. One is design iterations, challenge and solution, and continuing into next semester. Before that, I would like Guiming to talk more about what is edge computing.
Thank you, Dumont. Now, what is edge computing? Instead of traditional cloud server, edge computing as an extra layer. The new edge layer is between devices and cloud. So in this way, edge computing works as a local cloud server that moves the computation away from the data center in the cloud to the edge of network. So the new data center is much near the client side so that it can guarantee a high speed in transfer rate and shorter response time. So edge computing can provide us a low latency, high bandwidth network for games. For our project, we need efficient data synchronization during the fast-paced game process. So we use the efficient edge computing networking nature to implement the data transferring process. Next, Brendan will talk about our iterations.
Thanks, Guimin. As you may remember from HAFS, the idea that we ended up choosing for our game came from a personal experience that I had in college marching band involving reflectors on our helmets. This would eventually be what we call Disco Arena for our game. So Disco Arena, as it stands, is a 2-player AR game where players try to blind each other with their phones. Let's take a look at the demo.
So here's our demo. At the beginning, we'll show the players a tutorial that help them understand how to play the game. After the tutorial, they will scan the QR code at the center, and for the visualization. After that, they will begin to play. So let's pause here. So in our game, you can see those 2 players use their phone as a mirror to reflect the lights. There are different colored light beams. The blue ones is the one that you are reflecting. The yellow ones is the one that's shooting at you. And also in the light corner, you can see there's a mirror light bar. So the player had to dodge when the mirror is cooling down and it can't reflect anything. We also add those arrows to help players to differentiate the direction of the light, which is one problem we face during our playtest. Also, there's those light bars that So also the green box is the barrier. The player can hide behind that. So after you have 5 points, you will win this game.
So from a design standpoint, we receive feedback both from internal and external playtesters. Both agree that the game's core mechanics are fun and the competition is a welcome surprise for an AR experience. We also receive feedback, however, about visual feedback being a little confusing and how the game's core loop can get a little stale. So since HAFS, we've done a lot of research, brainstormed, and tested out different design directions, but primarily work was done to fix drift, which means making it less noticeable from a design standpoint for our play testers, getting the ratio of aiming your light to dodging your opponent's light closer to about 50-50, splitting the play field in half as opposed to a free-for-all style to help pare down our visual clutter and also aid in fixing drift, and implement a round-based system to help keep play segments short and distilled, combating our stale problems. I will now pass it on to Sally to talk about visualization.
Thanks, Brendan. So over the course of the semester, we held various playtests to kind of improve the overall design of the particle effects, the clarity of the light visualization, and the user interface and experience design. So the light beam is an essential part of our game, and we received a lot of playtester feedback to improve the overall look. And as you can see, we went through several iterations over the course of the semester. We found that playtesters could not differentiate lights closest to them, and we solved that by implementing elements like color-coded lines and particle effects to indicate direction, with arrows which aided the clarity of the overall gameplay. So now I'll pass it to Doris to talk about our user experience.
Thanks, Sally. Since we expect a lot of people with different age groups and backgrounds to play our game, we spend a lot of time refining the UI system to like players to be as intuitive as possible. We have added tutorials to minimize players' confusion about game understanding. Also, solving two main problems based on feedbacks from playtesters and faculties to perfecting our game. The first problem is how to allow pool players to start the game simultaneously. Before starting the game, we add starter screen to live players to set a scene and back to personal start point to hit ready. The second one is how to make two players to distinguish light beams come from. In this case, we create modal center screen effects to let players understand different light beams come from with different visual displays. Then I will pass on Leon to talk about our technical challenges.
Thanks, Doris. So for our technical side, during our implementation and design process of technical, we found some issues. We found some challenges. The first will be how to get the relative positions and rotation of both players based on the same marker in the same room scale space. Second will be how to ensure stable initialization of the marker image during the image tracking process. And the third question will be how to design and implement a network connection pattern between our front-end devices and back-end devices. Next. So to demonstrate the use of the edge computing system, we use the client-server pattern and push the most of the calculation process to server side, which means we need a more powerful device to compute most data calculation in the edge computing. And client devices will be roughly normal to run the game itself and just did the basic rendering part. And that just matched the scenario of the edge computing system. Next, I will let Dongmeng to talk about our direction of moving forward.
Thanks, Leon. So let's go over how we spend this semester first. As a label as Discover project, we come up with about 23 ideas during the 3 weeks. And there was 3 ideas we really love about. So we bring those 3 ideas to the faculties, and they highly stress us to choose one and dig deeper. Also, our client wants a game that they can bring to a conference that to do as a showcase. So we stick to a head reflector. And after halves, a head reflector became Disco Arena. And during the time, there were numerous design ideas were generated. But for the sake of time, we stick to the Disco Arena design. However, as Corona become more serious and the conference canceled, we talked with our client after soft. They were very happy about what we built and what we have explored during the semester. So they pivot towards like a further exploration, and they told us to decide to sponsor another semester to continue build on what we have built and what we have discovered. So they asked us, instead of implementing more features, they wish us to really document everything those research files and design files that could benefit the next team. They also that happy to want to publish a paper with us after the semester. So for our team, we focus more on gameplay in this semester. We wish the next team could focus more on actually do the showcasing in the conference.
So from a design standpoint, exploration falls more towards expanding on the core game loop and trying out different interaction interfaces. When originally pitched, our client had visions of trying out both a cooperative and competitive game modes for our guests to try at the final venue. However, due to time constraints, more priority was put on iterating the core gameplay. Reflecting light doesn't inherently lend itself to either game mode. So finding out which one works better now that competitive mode has been implemented would be one way for designers to find new territory to explore next semester. In terms of different modes of interaction, the common assumption to make about AR experiences is that we are usually restricted to the one device that we have in our pocket. We had the unique opportunity of our client being willing to lend us as many phones as we needed to get the experience running. It was refreshing to think of a phone as just a motion tracker with a screen rather than it being the only thing that you can interact with the world with. This means that you could attach like 4 phones to your body to use for rudimentary mocap devices or hanging them around the environment as floating screens. The list goes on, but unfortunately, research in this direction wasn't made until much later in the semester, which was something we were not willing to pivot for. In terms of showcase, typically with AR experiences, an auxiliary monitor is used to set up for passerbys to see the game player's perspective. Talks were had about the idea of being able to view experience on your own device with spectator mode. We're fortunate with Edge technology that it was specifically built to handle problems like mass volumes of devices connecting to one network. To have spectator mode would not only allow for a more personal experience for a third party, but also show off Edge Tech's ability to handle rendering and synchronization with little to no drop off on the user's end. This mode also opens up a myriad of different ideas to come up with audience influence experiences, which all would have been too much to implement on top of experimenting in this new space for all of us.
So for our technical side, one direction of further exploration is potential solution for fixing the drifting problem. So there is a system called acoustic location processing system, which using several ultrasound beacons in the room scale space, which can accurately detect AR space and combine it with the actual space. So there will be a very good chance to make a better combination of the AR system and make use of the edge computing system.
So for the showcase of Edge, this semester we showcase the Edge power by showing the network state like the latency, upload speed, and download speed from the Edge computing platform dashboard. But it's nice to explore how to show off the Edge power by comparing. For example, the Edge has power to show a higher fidelity and lower latency game than the cloud. So a game can be shown that's having a better performance and seamless experiences with the help of Edge instead of the cloud.
So from an art perspective, due to cancellations, a lot of focus this semester was shifted from preparations for the conference venue and more into the game design and gameplay. So with the added addition of possibility of spectator mode and having different perspectives on the gameplay, the next team can have a lot of opportunity to expand on what we create with the art. Spectator mode needs its different UIs, needs new assets, dashboard displays to kind of creatively and effectively show off edge computing. We also believe that the next team will also have the chance to explore what is possible in the physical space, environmental pieces, costumes, props, and other deemed assets.
So in summary, xroom created a Disco Arena, a multiplayer interactive mixed reality experience for mobile devices that people can enjoy in a room space. So we'll go over our semester. We thought this as our matrix to meet our client's requirement, to have the fun gameplay, to realize the technology to provide to us, and also to document the handover the files that could really benefit the next team. So we will thank to everyone who helped us and also the playtesters that help us to do the playtest. And this is Project xroom. We are open to questions.
All right, great job,
Yay,
team.
excellent.
Congratulations. So anybody with questions, you can throw them in the chat or raise your hand and Mike will help. Oh, I think Mike Chris already has a question.
Yeah, since you're all about edge computing, my question is whether you ran your game with no edge computing, then ran it with a light amount of computers, and then with a heavy amount of edge computing computers to show the difference of gameplay between no edge support, some edge support, lots of edge support. And how would you show the difference in behavior and difference in load between those three sorts of setups? Did you do anything like that?
So the answer is we are using the edge computing platform that our client provided is the advantage. So it's a really powerful system for us to use. It can not only provide us efficient and stable networking for our game, but also we could use the platform we can modify the latency and download and upload speed on the platform. So we could use this feature to simulate different networking situation. So we could modify the latency to have a longer latency than to running in cloud computing that have a longer latency. And we could run the game. We could experience the game in this kind of networking situations here. So we have already experienced some of the different game during the different simulation here. So we could feel there's a different short time between the player want to trigger for example, they want to trigger reflection light but there's a slightly lag on that. So we could use this way we could use the edge computing platform to simulate different kind of networking situation.
Thanks.
Don, you're ahead.
So you mentioned about in your playtesting, testers said it was slow or the motivation loop, you had to work on that. Then you jumped to how you balanced your aiming versus dodging. I'm curious if that and the cooldown was a response to that. Did it help? Is that what you used to make this more balanced?
Absolutely. Yeah, one of the pieces of feedback we got primarily was that because of the difficulty of aiming, players would eventually just stop and try to aim, and they wouldn't have much motivation to do anything other than just stop and aim. So a lot of the playtest we had subsequent was working on giving the players a reason to move from aiming, and so the best solution was giving the mirror a cooldown, so it eventually forced them to actually have to move out. And since both players aren't going to be doing this at the same time, one of them eventually is going to have to dodge the other's light, and that eventually made it movement a lot more dynamic. So
got it. Thanks.
Yeah. Additionally, we also test about like the time of the cooldown during our final playtesting to make it the dodging time is not too long and balance the time of the dodging and the aiming.
Time for one more. All right, thanks team. Good job. Congratulations. So if you all can mute yourselves, turn your camera off, and next up, the ignition can turn their mics and cameras on. I'll find you. There you all are hiding. Oops.
Can you see my screen?
Getting there. Two more. All right, that's all of you. Whenever you're ready.
Okay, can you guys hear me?
Yes, I hear you.
Okay, cool.
All right, let's get started. Good afternoon, guys. Welcome to our presentation. We're Ignition Animation, and we are presenting our animated short rhythm, 知音. Next slide, please. This is our team setup, and these are our faculty advisors. Huge thanks to our sound designer, Hannah, and voice actor, Ren Zhao, Peter. So just a quick summary. The goal of this project is to experience working in animation production pipeline, hone our art skills, and build unique and authentic art to strengthen portfolios. We're making a production, which is a short musical animated film adapting the Chinese legend High Mountain and Flowing Water. And we're making a pre-production, an animated thriller adapted from a poem, Fear of the Unknown, and that is going to the future team. Next, I'll hand to Chelsea to talk about our pre-production package, Fear of the Unknown.
Thanks, Rosie. So our pre-production package is a horror film. The story is from the poem Fear of the Unknown. The idea is to have a voiceover of the poem read out throughout the film. So the film is a literal visualization of the poem. As you can see here in our storyboard, the story starts with the character waking up in the woods, confused. He finds his flashlight broken, so he walked into the woods under the moonlight. He feels the forest is like a living creature. At one glimpse, the tree branches become eyes watching him. Then he reached a path with a tree moving on its side, as if it's inviting him to go forward. And he did. The forest is misty, and the fog is retracting while he's walking, as if it's leading him. Then he reached a place with a huge weird tree blocking the path. The fog stopped moving. It's at this moment a sudden fear came to him, and he turned around and saw his footprints deep on the ground, filled with blood. He was scared and tried to run away. The fast-moving tree branches chased him and killed him eventually. Can we go to the next slide, please? Though the poem didn't introduce the character, we figure it's going to help the future team if we come up with a background story of him. So we designed him as a 38-year-old British archaeologist who is also a Christian, come to this forest to explore. And the story happens in the year of 1905. Then AJ will talk about the environment and the tech of this pre-production package.
Thanks, Chelsea. Here we have some concept environment art to showcase how we envision this piece to look like, a dark and scary forest that entraps our main character. Pitching the project as a mixed media where we expect the team to track 3D objects in real environment. The environment concept images that you see here are actually real life locations. Bonus points to people who recognize this place. If you see the next slide, they're from Shenley Park. In the next slide, we want to show a quick demo of that we prepared to prove the pipeline on tracking 3D objects that could help the future team. We were able to follow tutorials step by step, taking stock footage and taking some stock models and tracking them together. We do acknowledge the fact that the pre-production package that we're pitching is a little non-traditional. That's why we prepared a bunch of documentation listing down tutorials, as well as best practices from our own experiences from our personal projects that could help both seasoned as well as beginner students alike. On the next slide, having worked on the animation semester ourselves, we realized that a single person tends to wear more than one hat in this project. So here are some of the few ones that we suggest having on the team so that the team could benefit, essentially creating the best portfolio pieces that they can. All of that said, now we shall be showcasing the final cut of our production film rhythm. Please enjoy. We will also be putting the link in the Zoom chat in case of technical difficulties or for future reference.
伯牙善弹七弦琴，是一位享有盛名的乐师。他的名声流传于他的挚友之间，乃至当朝圣上无人不知。人们深爱伯牙的琴声，伯牙也一跃成为了最受宠爱的乐师之一。但伯牙的内心深处仍盼望着一位能听懂他琴声的人，他无比孤单。直到有一天，
Thanks, AJ. Next, we'll just give an overview of the art in our project. So we have done some research during our initial days about the character, time period, and the cultural references, and also the clothes these characters would wear. We even researched and stuck to some of the key features of ink style painting, like using fog, heavy character outline, and paper-like texture. Next slide, please. For the character design, we took reference from Chinese history and paintings to come up with authentic character representations of Boya, the zither master, and Zichi, the woodsman. Next slide, please. Since softs, we have tweaked the animations as per the feedback and also added appropriate cloth simulation using Houdini. Here are some results of the cloth simulation on the final cut. Next. We used environment to convey the mood and different times of the story. Each time period has a specific color palette, and we used ink swipe transitions to switch from one scene to another. Next, Isaac will talk about technology.
Thanks, Lucy. So I will talk about the tech part of our project. In our early stage, we researched a lot about how to implement the unique art style we had on our concept art. So here we try to use the real-time ink simulation, but as you can see on the right, there are some artifacts when the camera moves. So finally, we decided to just combine outline shader with hand-painted texture because that will be more art directable. We have a lot of VFX in our product. For example, the leaves, the wave, the rain, and the fog. All of these are made by Niagara particle system building our engine. For cloth simulation, we used Houdini Vellum to do it. And for other tools we have used the sequencer building our engine to lay out our shots and rendering things out. Of course, we have built our own tools. For example, here, the tools can turn a realistic object into a stylized one with only one click. We met a lot of issues and we have gone through a lot of troubleshooting during our process. We can go deep in the QA session about this. So now let me introduce Karen to talk about our pipeline.
Thank you, Isaac. Let me talk about our production pipeline. Next slide, please. We received pre-package from previous semester's team. Then we made a 2D animatic based on the story. Next, according to our researches as well as feedbacks we got, we improved the story. Then we began to make 3D animatic based on our new story. While we are working on the camera movement, artists in our team also started to make art assets, and we contact our sound designer Hannah to help us make the music goes with our piece. As we are keep working on the animation shot by shot, we also did several playtests to collect feedbacks from those people who has a fresh eye on our animation. We sent out the video link and asking our playtesters to take a short survey. For example, how do they read the story in our animation? Does the color palette works for them? And does the ink transition work or not? Based on those feedbacks, as well as our halves and softs feedback, we did some updates on camera movement, timing, animation, and staging. Finally, we composed all the shots along with the background music into our final render. Next slide. Those are the tools we used. For modeling, we used Blender, Maya, and ZBrush. For texturing, we used the Substance Designer, Substance Painter, and we used Procreate to hand paint ink style texture. For animating, we used Maya. For visual effects and clothing, we use Houdini. For rendering, we use Unreal Engine 4. And for compositing, we use Premiere Pro and After Effects. Next, Rosie will talk about lessons learned.
Yeah, thanks, Karen. Now I'm going to briefly summarize some lessons we learned throughout the semester. First, leave extra time on new techniques like cloth spin. Plan early, prioritize work according to its importance to the whole piece and our skill set. Third, keep updating the documentation for future team. And last, make standards for assets from the beginning to avoid repetitive works. Next slide. Special thanks to all the individuals that provided help to our team and our playtesters. Next slide. Okay, then once again, we made a short animated film adapting the Chinese legend, High Mountain and Flowing Water, and we made a pre-production package for a future team. We're Ignition Animation. We're now open for questions.
All right, great job, team. Congratulations. So if anybody has any questions, just throw them in the chat or raise your hand and Dave will help filter them in.
Go ahead, Ralph.
Let me unmute first. So team, what was your biggest challenge? What do you think was your one singular biggest challenge, both on the tech side and one on the narrative story side?
Okay, so I think I can start by mentioning the narrative part first. So when we received the prepackaged, we had a lot of discussion regarding how much true we want to stay with the original narrative because we're adapting it from a Chinese legend, as well as kind of adding our flavor to it. And at the end, we realized that not only did we want to just respect the original piece, but we also wanted to trust our audience. So locking down narrative took us longer than we wanted it to. I think that is one thing that we maybe, if the team would want to do it earlier, that would have been better for us. But at the end, we were able to come up with something that was cohesive enough that not only did it respect and took from the original piece, but also addressed all of the confusion and all of the doubts that the audience had. So yeah, that was one of the narrative challenges that we had, I guess one of the bigger ones. Isaac, would you like to add on to the technical ones?
Yeah, sure. I think for technical part, our biggest challenge is to recreate the unique look of our product, because we want to recreate the traditional Chinese painting style in our piece. So we actually did a lot of research in our early stage, and most of them just have a lot of issues. So we finally decided to use the outline shader with hand painted texture, because that will make the piece more art directable. And yeah, and also we need to combine the piece with code simulation. So we have to make the code simulation make it match our art style. So we have to do a lot of tweaking things on that. So yeah, I think that's the most challenging part of the tech.
Thank you.
I've got a question. You guys mentioned that you used surveys as a way to get feedback on this. I'm curious how that process compared to more traditional ways of getting feedback. And if there's anything that those surveys identified that you couldn't have gotten any other way.
I would say with the survey system, it was we were able to share our piece with more people than we would have had without sending it electronically, having people in person. One thing that the surveys helped us to get information about was in general interpretation of the piece as we were iterating on it, and we realized that, I guess I had mentioned earlier about trusting our audience, we realized that people were able to understand our story as we were iterating on it, which meant that we were going in the right direction. And sending out multiple surveys helped us get that information way faster than scheduling in-person screening of our animation, basically.
Cool. Thanks.
Time for one more. All right. Well, congratulations, team, and congratulations to all the teams who went today. Good job. So thank you all. Have a great rest of your day, and faculty will see each other in another Zoom shortly.